Kia ora, Year 11 and 12. Here are questions 3 and 4 from the May 2019 AS paper. So the first one's a geometry one, and then the second one is one about a trapezium, and you can solve that one in 2 different ways. So I want you to pause the video now and have a crack at both of those questions, and then I'm going to work through them. Question 3 is pretty easy. Question 4 is easy if you spot one thing. So I'm going to give you a clue now for question 4, and it's that right angle there. Okay, so pause the video and then I'll work through them. Okay, so here's question 3. Grab your formula sheet if you need it. Hopefully this close to the exam, you don't need it. We've got a sector of a circle of radius r centimetres has got an area of A. So here's my sector, and we know that the formula for the area of a sector is 1/2 r squared theta. Theta's this angle here. We have to work out the perimeter of the sector in terms of r and a. So the trick here is not to just think that the perimeter is this bit here. The perimeter's got 3 sides to it. Right, so let's get an expression for the perimeter. P is going to equal 2r plus this arc length here, and we know that the arc length is r theta. But we don't want to have our answer be in terms of theta, we want to have it in terms of r and a. So we have to rearrange this to make theta the subject so that we can then eliminate theta from in here. So we've got 1/2 r squared theta equals a. Rearranging that gives us theta is equal to 2a over r squared. So we now can take this and we're going to substitute it into here. So P is equal to 2 times the radius plus the radius times the angle, expressed in terms of the area and the radius. So we get 2r plus 2a divided by r, and that's it. I think that was worth 3 marks. Okay, so I think that's a pretty easy question. As usual, it's worth 4 marks. So that's pretty generous. Make sure that you have a good look at your formula sheet. Remember that you don't get the formula for a segment on it, but you don't need it for this question anyway. You do get the arc length formula and you do get the sector formula, but you really should know those by now and not be having to rely on the formula sheet. Okay, question 4 is a little bit trickier. Question 4 goes like this. So we've got a trapezium and we're given the coordinates of A, B, and C. And C is H, 3H. And we're told that BC and AD are parallel to each other. And the most important thing in the question is that this angle here is 90 degrees and CD is parallel to the x-axis. So the first thing we have to do is to figure out the value of H. Where's my pen gone? There we are. So that's going to be point C. So there are a couple of ways to work with this, but the key to it is to see that to find the angle of BC, we can use the fact that perpendicular lines have gradients that times together to give -1. And we know that these 2 lines are perpendicular. So what we're going to do is find the gradient of AB and go from there. So the gradient of BC is going to equal the change in y over the change in x, which is 3h minus 2 over h. And we need to know what that is. Now we know that the gradient of AB, that should say x, is equal to the change in y over the change in x. And we can use numbers for that because we know the numbers for points A and B. So that's equal to -2 over 4, which is -1/2. That gives us the gradient of BC equaling 2 because they're perpendicular lines. So now we can go back up here and solve this equation. So we get 3h minus 2 over h is equal to 2. 3h minus 2 is 2h, giving us h is equal to 2. So that's pretty useful because now we can figure out the rest of the problem. I think that was the first part of the question. That's the first 3 marks. So point C is equal to h, which is 2, and 3h, which is 6. So now we know that point D, well, CD is parallel to the x-axis, so D is going to have a y coordinate of 6, and we don't know the x coordinate yet. But we know that this line is parallel to this line. And we know that the gradient of this one is 2. So the gradient of this one we're now going to solve to give us the same gradient. Right, so MAD is equal to what? Well, here's point A and here's point D. So it's the change in Y over the change in X. So that's 0 minus 6 divided by 4 minus X. Now I'm going to go back up and show you where that's coming from. So here's point A, and that's its coordinate values there, and there's point D. So we know that MAD must equal 2. That gives us negative 6 is equal to 8 minus 2x. Something's gone wrong. Oh, no, that's right. Negative 14 is equal to negative 2x. So x is equal to 7. So the coordinates of point D are 7, 6. But there's a much easier way to do this problem. So that was fine using coordinate geometry. I'm going to get rid of all of this now, and I want you to think about how you can do it using vectors and the dot product. And that's if you're in the AS class this year or the A-level class. Right, so both of you should know something useful about the dot product. So we've got this vector here, thinking of them now as two vectors, and this vector here, and we know that they're perpendicular. So let's write BC as a vector, and it's going to be 3h minus 2 and h. And vector, which way am I going to do it? Doesn't matter. I'll do AB. Vector AB is equal to 2. Be careful here. So x coordinates. So from A to B. So 0 minus 4. And then for the y coordinate, 2 minus 0. And we know that the dot product is equal to 0. So that gives us 3h minus 2. H dot negative 4, 2 is equal to 0. And we get negative 12h plus 8 plus 2h is equal to 0. Something's gone wrong there. That should be a negative 2. I think, hang on, this is from A to B. Right, so hopefully you guys spotted my mistake before I did, and you're probably watching this going, man, she's having a stupid day today. Look, here's my vector here. This is the one that was wrong. It's so easy to muck this up. What did I do wrong? Well, I started by looking at the y values, and I did that because I'm really used to doing this when I find the gradient. But I need to be looking at the change in the x values. So this vector here should not be 3 minus 2h. It should be h and 3h minus 2 like that. Remember that usually you're going to get easy numbers in the Cambridge exams. So if you see that you're not getting a nice round number, it's worth checking it back to do it. I was trying to show you that this was a really good way to do this question, but I don't think you will think that now. So there's negative 4h plus 6h minus 4 is equal to 0. 2h minus 4 equals 0, and you get h equals 2. So if you compare the amount of work in doing it using vectors to doing it using coordinate geometry, you can see that the vector approach is much, much faster, and we can very easily then get the coordinates of D. I'm not going to go through all of that again, but using vectors to get the dot product is a really nice method. Okay, leave me any questions in the comments space, and let me know if this is helping. I'll do some more YouTubing probably sometime tomorrow.